Hi everyone, this is Duke here with a video on the Boxkite build for our VTOL class this semester. I forgot to pull up. Our Boxkite this semester is based on a forum post by Henry, one of the Ardupilot developers. And he had built a Boxkite a few years ago now. It's been almost 5 years. I found this a while back, a year or two ago I think, on the forums, and that looked kind of cool, interesting, and we ended up doing that for our build this semester for class. So Henry's got some good instructions here and diagrams and stuff like that. He built his a little bit differently, but not really any major differences. And so we're going to be building ours this semester, and this video is how to do that. As I already have one built, I thought the best way to show this would be to show you some diagrams that I've added to our class TL draw, and then to show you the physical plane here on the bench. So we should have both things working. Here's the physical plane, and I'll show you the diagrams here in just a second. So overall, we have the Boxkite frame. Let's see, this being the top, okay? And it's relatively simple. I made out of foam board. Dollar Tree foam board works fine. I have the flight test stuff with the water resistant coating on it, so that's why it looks a little bit more shiny perhaps. But overall, it's a pretty simple build, and it got more rigidity than I thought it would out of the skewers and stuff here on the side. Anyways, let's flip over to the diagram. We'll kind of talk through each part of the build, and then we'll flip back to the aircraft and kind of go back and forth a little bit. So let's do that. Okay, and there we go. All right. So in the TL draw for our class, you can find that on the home page here, class TL draw. I've added this diagram, which is just kind of over to the side from the wiring diagram stuff we were talking about before. And the nice thing about TL draw is it's kind of like infinitely scalable, I guess you could say. So you could put things wherever you want, however big you want, I guess. But here is the breakdown for our Boxkite build. So I have a parts list over here on the right hand side. These are all the different bits and pieces you should have, including electronics as well as physical structure. And then here we have just a note about the foam board sheets. So basically this will take about 3 foam board sheets of the 30 by 20 inch size that is typical, at least in the United States, for this size of foam. And so I have these 3 here in the black rectangles. I wrote white rectangles, but I forgot mine was in dark mode when I was doing this. So black rectangles, white rectangles, you kind of get the idea there. We have 3 sheets of foam, and they're broken up in the corresponding layout. So we have, let's start here with the bottom left. We have our top and bottom wing structures. And this is, again, a 30 by 20 sheet. So we have the measurements here on the side, 10 inch and 10 inch. And the bottom is 30, as mentioned up here. Okay. So we're going to cut that 30 by 20 sheet in half along the green dotted line here. And we have 2 30 by 10 inch pieces of foam. Those pieces of foam will be what makes up the top and bottom main wing structure. So this piece right here that is underneath, there's another little piece here, but the main piece is 10 here by 30 here on both the top and the bottom of the plane. Exactly the same there, with the addition of the ailerons, or I guess elevons, on the bottom, which we'll talk about in a second. So that's that piece there. Let's go back over to this. We have our bottom wing getting some elevons cut out of it. That's one difference in our design compared to Henry's design. He had some elevons that went across to the other wing with a cross link. I didn't want to do that if I didn't have to. It didn't have to, and it didn't seem necessary when I test flew this. So we're just doing one set of elevons on the bottom wing. And if we go a little bit closer here, we can see on the bottom wing, you're going to go in an inch from the edge of the wing. You're going to cut a 12-inch by 1.5 inch elevon, and that will mean you score the section here that's the hinge and then cut through the sides so the elevon can move. You do that on both sides of the wing, so just measure an inch in from both sides, cut a 12-inch elevon, 1.5 inches deep, and then you can score that, but don't, of course, cut the elevons off the plane. We don't want to do that naturally. And those would be right here. So down here on the bottom, going to see there. Okay, there's our elevon. We would, of course, cut here Sorry, it's hard to do this with the camera view. Cut here and here. And then we have the score cut along here, which we later will bevel to allow it to actually move, like an elevon would, and have that hinging structure on the wing. Okay. There we go. All right. On the props. There we go. Okay, back to the diagram. So that's our first sheet of foam. Again, just cut it in half and then cut the elevons out of one of those halves. Let's move on to the next foam wing or foam sheet here. We have the second sheet, again, 30 by 20. And so we're going to cut this in half first, and you have two 10 by 30 sections. One of those halves we're going to cut in half again. So end up with two 30 by 5-inch sections, which will be the top wing and bottom wing KFM step. And then the bottom half of the 30 by 20 sheet will be cut into three 10-inch squares, with one of them kind of being an extra square. And two of those will be the vertical edge struts, or the supports between the wings. So we have our top and bottom step and the two vertical struts. Let's take a look at that. So the KFM is this strip right here. It goes the length of the wing, but it's only half the chord length of the wing, so 5 inches by 30 inches. And that's top, and goes on the bottom wing as well. Kind of see that in there. Okay, all along the bottom. So you'll basically have two wings at this point that have been cut out all the way. They have the KFM steps ready for them. And then the vertical strut pieces are going to be this one on the one side and then the other side over here. Okay. The center will be a special case, but you have both sides end struts cut out as well. All right. Okay, back to this. And we have our third piece of foam board. This one will get cut into three pieces of 10 inches by 10 inches by 20 inches each. So the 30 by 20 gets cut this way, and I'm sorry I didn't draw this exactly right, but those are supposed to be 10 inches along this top and bottom dimension, 20 inches along the side. Okay. What we're going to do with these, we're going to use them, two of them for the center nose vertical structure. As I talked about in class a little bit, the center of gravity, I think on mine is not quite far enough forward perhaps, and so to just kind of take care of that just in case. Once I have a chance to test it somewhere, I'll know for sure. But either way, we'll cut out two pieces that will be the center vertical strut, and that will allow us to have plenty of distance to kind of round off the nose. We can say kind of a hemisphere shape in the front to give us plenty of nose for the airplane to move things forward and get a better center of gravity. So on mine here, I have the centerpiece being 10 inches, the same as the other two. Okay? But on yours, this part will extend farther forward to allow us to move the center of gravity forward if needed on the aircraft. So that'll be that piece there, and you'll also have two of those to give us some extra rigidity since it's going to extend beyond the center of the actual two wings. Additionally, on that centerpiece, if you can see this here, let's see, you'll need to create a little bit of a step to go up over the KFM step, so just kind of a little jog in the foam. I didn't bother drawing that. Figured that would be intuitive enough as is to kind of create a little jog so that those pieces can slide in right on top of that KFM step. The end pieces don't need that because they go on the outside of the entire structure. So we don't have to step these at all, they just go on the outside. And the center one's the one that has to get that little jog in it to cover the bottom wing's KFM step. All right, so there's those components. And then additionally in the list of things we need, we have our parts list. We have the barbecue skewers, the mount for electronics, the motors, all that kind of stuff. So we'll look at that real quick on the dot cam, or I guess not dot cam, but on the camera. Okay, so the barbecue skewers you can see here, and on the other side is identical basically. We go measure about, I think it's about 4 inches down, and we'll drop those through so we can go through both the wing and the KFM step. Okay, maybe not 4 inches, I need to actually measure that. We'll drop that through so it goes through both the step and the wing on both sides. Okay, and we align those to be about the same distance down here, so they're not like slanted at all. They should be a roughly horizontal inside the plane. And we're going to put them relatively close to each other so we can hot glue them together as well. So there's a joint right here is also kind of joined with hot glue to keep the spars, or not spars, the skewers together. So what I did with these is I measured down one side, put it in, measured on the other side, put it in, got that one in place, and then just put the other one slightly above it or slightly below it, depending on how you're thinking of it. And that will allow those to be crisscrossed, close enough they can be glued together. Sorry, this camera angle is a bit strange for me. And then we will allow them to protrude through. When we're gluing them, once they're all glued in place, then you can snip the excess off and put a little bit of glue over if you want to kind of keep it from getting splinters or things like that. And that's what will happen on both sides with the barbecue skewers. So those are just kind of act as bracing for the top and bottom wing into the side panel, and feel relatively sturdy. It was sturdier than I thought they would feel. And that's the same on both sides. Okay. Let's see, there we go. Both sides are identical. Okay. We have our motor mounts. Okay. You can see here it's just a 3D printed mount the motor's mounted on. The ones I have on this aircraft are adjusted for a single layer of foam, so I had to kind of cut out the foam there. But the ones I'll be giving you will be the thickness of 2 sheets of foam, so you can just slide them on in place and install those. The position of the motors is just half on each side. So if this is, say this would be about 15 inches in the center. These are placed at half. Okay, so they're centered, of course, is nice. And then all 4 of them are identical. So we have the same motor mount on each one, just mounted on their respective wing positions. Okay. That should be pretty straightforward. Our servos are mounted, and I actually realized I didn't quite mount these symmetrically later on. Didn't realize this until later. But I tried to mount them roughly right behind the step on the bottom wing, okay, and then make the push rods the appropriate length. Since we're gluing the servos down, there's some fiddling to do to just make the push rod the right length, and then place the servo where it lines up to get the elevon centered. So that's what I did there. You'll see this one's a little bit farther back on this side than this one is. I didn't notice that until later, but not a huge deal. It's going to be super precise here. We just want to try to get the servos as far forward as we can to help center gravity, but I thought behind the step would be okay in terms of placement of the servos. So you'll do that, measure your push rod, bend it up, get as close as you can, and then glue the servo down with the surface centered, of course. So we make sure we get nice consistent line up there. Just like when you're building one of the flight test planes, we want to make sure we center the servo first, and then start gluing things down so we get a nice physically centered control surface, not just having to mess with the electronic trim and things like that. All right. Our electronics in the middle of the plane will be centered on one side of the nose brace, or nose strut, I guess you could say. Yours will be a little bit different. Mine is spread out. Yours will be just a single stack of the electronics mounted roughly in the center. We have the battery harness or battery lead going over here to mount the battery on the other side with that strap, okay, right here. So that will help things stay, roughly symmetrical. And we have that flight controller mount double-side taped to the foam after we've installed the screws and everything through the 3D printed mount. The battery, we have a bit of UMA grip over here to hold the batteries in place, and then we have a strap that'll go through the center section to the 3D printed mount that the electronics are on, and that allows it to kind of strap together, keep everything together on the plane. Okay, and that should be a good way to do that. All right, I wanted to show you one of the flight controller mounts. So this is the type you'll have, like so. So the Velcro strap will go through there underneath the electronics, which will be stacked on top of this, and the strap will then feed through the other side of the foam. The holes here are for mounting the screws to hold your electronics, and so that's what your flight controller ESC mount will look like. And again, that's just that piece here that everything's kind of mounted on for the electronics. Just a note, wherever you're going to do double-sided tape or the VHB tape, I would recommend putting packing tape on the foam first. It really helps the VHB stick better. And so I've done that. You can kind of see the shine when I move it around. I've done that most everywhere on this section of the plane, and then where the GPS is mounted. The only exception, I guess, is where the servos are mounted. I didn't use VHB for those. I used hot glue to mount the servos, so those don't have tape underneath them. But if you're going to do anything else mounting with a VHB, I would recommend putting some packing tape on the foam before you stick the VHB down. Set this up that way for right now. Anything else we can think of? I think that's it for the build. Oh, the GPS module. Let's see. GPS module here is on the top. It's mounted obviously up towards the sky, and it's just routed down here to the flight controller. You can calibrate the compass any direction you want, so I just wanted to have my wires come out the side here, not come out the back, and have to go back around. I just mounted in that orientation, and it looked like it worked pretty good. So that should help you get your VTOL build started and give you the measurements you need again in the TL draw for our class. So we'll go back to that real quick. All right here. Let me know if you have any questions, and I really think this will be a cool build for us this semester to allow us to test out some VTOL stuff. Thanks.